So before I show you how to find the length of this line, I want to take you back to this famous triangle. It's a simple right angle triangle with side lengths of 3, 4, and unknown. Now we all know how to find the length of this side, right? We just use Pythagoras Theorem, and many of you will be aware that this length is actually 5. But if you look at this line, you could make this into a triangle, right? You can make this into a right angled triangle. And Pythagoras' rule states the square root of a squared plus b squared is equal to c squared, is equal to c, right? Well, we could technically apply that into this, but only if we knew the lengths of these two sides. That's easy, isn't it? Similar to how we found gradient, we can say that this length, this height over here, is y2 minus y1. And we can say that the length of this bottom part of this line is x2 minus x1. So with this information, we know that the height of this line is equal to y2 minus y1. And we know that the length of this line is equal to x2 minus x1. And now all we have to do to find the length of this line is apply it to Pythagoras' theorem, right? And just so I don't mix you up, the basic Pythagoras theorem is a squared plus b squared is equal to c squared, right? But we just simplified it with the square root by removing the square over here. So we could say that the length of the line, L, let's change the sign of this. Let's just call this x, right? Because it's the length of this x part of the line. And we'll call this y. Okay? We can say that the length of the line, the black line, would be equal to, we can say that the length squared would be equal to y squared plus x squared. Right? But we don't want the length of the line squared. We want it the actual length of the line. So, well, we can say L would be equal to the square root of y squared plus x squared. And that simplifies it a lot for us. Now we can say that the length of the line will be equal to the square root of y2 minus y1 plus x2 minus x1. Okay? And that is the basic way of finding, these two are squared. And that is how you find the length of any line. Okay? So now let's apply this to a line that actually exists. This is the formula of how to find the length of any line. Okay, and we've derived this from Pythagoras' theorem. And it's a great way to illustrate it, by the way. So instead of these imaginary points, let's give this line, let's call this point 5 and 7. And we can say this point is 2 and 3. Okay? Now it's simple. All we have to do is substitute into this formula. So we have L, the length of the line, would be equal to the square root of y2 minus y1. So y2 is 7, y1 is 3. Okay, and remember to square this. Okay, sorry, it's minus. Plus 5, which is x2, minus 2, and square the entire thing, the entire brackets. Right? When we apply this, we know that this will be the square root of 4 squared plus 3 squared, which is equal to the square root of 25. And if you actually look back to this, we know that this will be 5. So the length of this line is actually 5. So using this simple formula, which we have derived from Pythagoras' theorem, we can find the length of any line in the xy plane.